Welcome IGCSE students. We're working on our power rules or our index rules today, and I just wanted to refresh you with the three rules that we learned probably back in year 9. First of all, rule 1, when we have x to the power of, let's say, a, and we multiply it by x to the power of b, we get x to the power of whatever a and b sum to, a plus b. So the first rule is, when multiplying powers with the same base, you add the powers. Just make sure that you're thinking about multiplication here. Sometimes when people have things like x to the power of 2 plus x to the power of 2, they go, oh, that must be x to the power of 4, but of course it's not. It would simply be 2x to the power of 2. So this rule is for when you're multiplying powers with the same base. Okay, our second rule is this rule here. When we have numbers, powers with the same base, the base here is x, we divide them, then we subtract the indices. So this would be a minus b. The third rule, and this one people get sometimes a little bit confused with, when we have powers being raised to another power, we multiply these. So in this case, x to the power of a all to the power of b would be x to the power of a times b, or ab. So now what we want to do is apply this knowledge in our textbook exercise 12.2. So from our exercise, here are some of our examples. 2 to the power of 5 times 2 to the power of 4. This is rule 1, so we're going to add the indices. The base is 2. It will be raised to the power of 5 plus 4, which is to the power of 9. This one here, 6 to the power of 4 divided by 6 to the power of 7, will be 6 to the power of 4 subtract 7, so 6 to the power of negative 3. 5 to the power of 6 divided by 5 squared times 5 cubed, so this is 5 to the 6, and this one is 2 plus 3, 5 to the 5. So this will be equal to 5 to the power of 1, and we can simply say just 5. So if it's to the power of 1, you don't need to put that power in. 10 to the power of 4 all squared, that means 10 to the power of 4 multiplied by 10 to the power of 4, so this is 10 to the power of 8, 2 times 4, that's rule 3. Again, rule 3, but this time we're using a letter, so c squared cubed is c squared times c squared times c squared, so c to the power of 6, 3 multiplied by 2. Now this one here, we've got some coefficients in here, so this makes things a little bit more interesting. 5 times 3 is 15. P to the 4 times p to the power of 7. So this will be p to the power of 4 plus 7, which is p to the power of 11. Now, I've chucked this one in. Y to the power of 0. Well, anything to the power of 0 is equal to 1. And if you can't remember why that is, let's do an example. You know that x to the power of 3 is x times x times x. Let's say we did x to the power of 3 divided by x to the power of 2. Well, that would look like this, wouldn't it? Right, x to the power of 3, and you can see simply we'd cross this out, and we'd be left with x to the power of 1. But what if we changed this slightly and divided by x to the power of 3? So on the bottom we'd have 3, and you can see that by our rule, 3 minus 3 would be 0, x to the power of 0, but anything that's divided by itself is obviously 1, and that is why anything to the power of 0 is 1. Let's move on to these ones here. Now we've got some negative powers. R cubed to the power of minus 2. We're simply going to use rule 3 again. 3 times negative 2 is r to the power of minus 6. At this point, you might want to refresh your memory on negative powers. R to the power of minus 6 is equal to 1 over r to the power of 6. And again, we can use our simple ideas to help us with this. Let's say x to the power of 2 divided by x to the power of 3. This looks like this when we draw it as a fraction. Over. Right, now we know, using our rules, that it should be x to the power of minus 1. And if we cancel this out, we end up with 1 over x. So this is how we are able to switch between positive powers and negative powers. So x to the power of negative 1 is equal to 1 over x. X to the power of negative 2 is equal to 1 over x to the power of positive 2. So hopefully this is a refresher for those of you who have done the Year 9 course. Okay, last one here. We're going to use that knowledge that we've just done to flip this. We can say that this is equal to t over 6 to the power of positive 2. And therefore we have t squared over 36, right? T over 6 times t over 6. Now if you are struggling with how I got from here to here, you can think, remember, this is like this as a positive power. But 1 divided by a fraction, you flip and times, so that's why we've got to here. Just remember your ordinary fraction rules that you're very familiar with, I'm sure. Now we're moving into some fractional indices. This gets maybe a little bit harder for us, but we've had some experience in this, so I'm sure we'll be okay. 121 to the power of negative 1/2. So we could say straight away, we know that this is going to be equal to 1 over 121 to the power of 1/2, using the rule we talked about with negative indices. Now, to the power of a half is equal to the square root. So we're doing that. And we know that that is going to be 1/11. So the bottom number, the denominator of the fraction, will tell you if it's a square root. If it's a 3 here, it will be a cube root in this case. Right, so here we're doing 2/3 to the power of 2/3. This is another way of saying 125 cube root squared. Or you can square the 125 then cube root. So what we're going to do here, it's easier to cube root here. 125 cube rooted is 5, right? 5 times 5 times 5 is 125. And then 5 squared is 25. So that's the answer to this one. So take the bottom one, cube root, and then square. That's to the power of 2/3. Let's try this here. 7 over 7 y to the power of 3/5 divided by 35 y to the power of minus 2/5. Okay, so 7 over 35, that's 1/5, I think, isn't it? 7 5s are 35. And then we just use our ordinary rules. 3/5, since it's the same power, minus, so this is rule 2, 3/5 minus minus 2/5, and that ends up being 1. So y to the power of 1, or just y. Or we might even say y over 5. That's probably a nicer way of writing it. This one here, we are taking the power to 3/4. So we can write this as d to the 16, and we're going to take the 4th root of that, and then we're going to cube it. 4th root, and then cube. And that's going to be over the same thing here, the 4th root of 16, and then cube it. Well, what's the 4th root of d to the power of 16? We're timesing 16 by 1/4. So that's going to be 4. So it'll be d to the power of 4, and then we cube that. So this will be d to the power of 4 cubed, d to the 4 times d to the 4 times d to the 4. So this should be d to the power of 12. And on the bottom here, we're taking the 4th root of 16. Well, that's 2 times 2 times 2 times 2. So this will be 2, this bit here is 2, cubed, which is 8. So that should be our answer to this one. This one here, we're solving for x. Another way of writing x to the power of minus 1 is to say 1 over x to the power of 1. And now we've solved our problem very easily. X is therefore equal to 10. This one here, 1 over 81 is equal to 3 to the power of x. We know that x must be a negative number to get a fraction like this. And you know that 3 times 3 is 9 times 3 is 27 times 3 is 81. We know that 3 to the power of 4 is 81, so 3 to the power of negative 4 equals 1 over 81. Therefore, x is equal to negative 4. Well, I hope that gives you a little bit of help and guidance as to how to get straight into this exercise. Do your best, and as always, if you're having trouble with any of the questions and you don't understand how to do them, send me an email and I'll either do another video for you or send you some instructions to help you. Alright guys, I hope you have fun with this. Good luck.